Good evening, guys. My name is Dhanashri. Today, I will explain the Bitcoin price prediction, how it is used in real world. First question is that what is a Bitcoin? It is a digital currency created in January 2019 following the housing market crash. It follows the idea set out in a white paper by the mysterious and pseudonymous Satoshi Nakamoto. The identify of a person who created the technology is still in mystery. Bitcoin offers promise of lower transaction fees than traditional online payment mechanism, and it is operated by a decentralized authority unlike government issued currency. Okay. There are no physical bitcoins, only balance kept on a public ledger. Then everyone has a transparent access to that. Along with all Bitcoin transactions is verified by a massive amount of computing power. Bitcoins are not issued or backed up by at any banks or government, nor are individual Bitcoins valuable as commodity. Despite it is not being legal tender, Bitcoin charts are high on popularity and has triggered the launch of hundreds of virtual currency collectively referred to at altcoins. What is Bitcoin? It is a decentralized digital cryptocurrency. Peer-to-peer transaction is available. 1 BTC equal to 16,426 USD dollars today. Enabled by blockchain distributed immutable ledger mining record keeping service. Wallet stores information to transact bitcoins. What is a Bitcoin price prediction? First time Bitcoin users 10 into times this year. Highly volatile in nature, difficult to predict, very high returns than conventional financial trading. Many newbies want to join every day. Data collection. Collect three types of data. Okay, predictive models. There are two models. First, traditional time series deep learning model. Okay, I will open the Jupyter notebook. Okay, into that first I will import all the library which is required here. First is import MATLAB plotlib library as PLT. From date and time import time data. Import panda as PD. Import number as NP. Import date time. Import time. Another is I will import the data model which required a model.data.csv file. Import data. Okay, first command model data.head. I will check the data is null or not. Model.data dot is null, passing the values dot any method. Okay, the output is false. The next command is model.data. Model.data passing parameter date. We convert the date into specific format. Okay, then splitting data and testing data. I will split the data into form testing and training data set. I will convert the 20-80% data into training and testing dataset. Create an object training test set equal to test model dot data. Split the model training set equal to training set dot draw date comma 1. Then I will print the length of training dataset. And next module I will import the plot ly plot as py. Import plot t dot graph objs as input pandas per pd. Then I'll convert the training into Go-scatter form. Fixed model data, passing parameter date and day is less than split date as type of date of time. Then create a y equal to model data model, passing date is less than the Bitcoin close. Okay. Then name equal to, then line equal to DICT color, passing the color into form. Then test equal to Go-scatter. When first is converted into training set and then second one is into test. Go-scatter equal to created two variable x and y, passing the model data, date and time, and Bitcoin close value. Okay. Then I will generate a code. I will check the length of the data frame. Then Windows len equal to 32 create equal to training inputs for I in range length of training data. Set Windows close. Test inputs. Then print the output of this data. Check the here I will print the length of outputs predicting the 45 points in the future. Okay. Create and for loop for I in range length tester set Windows -9. Okay. Then print the length of output is display output is 157. Another predictive model I will create training outputs for I in the range passing the parameter Windows length of training set, passing the parameters is the Bitcoin close, predictive range, training output is append to the using append method we passing the parameter training set bit close value I equal to predictive range dot values. Training outputs equal to np dot array in bracket training outputs. Okay. Testing output equal to for I in the range. Another for loop is there. Passing parameter Windows length and length of test set to predictive range. Okay. And here display the output. Printed training input dot shape. Printed training output dot shape. Printer test input dot shape. Printed testing output dot shape. You can check the here the values of the out of the total is there. Then import Keras module. From Keras module you required a sequential import activation and import then also import LSTM also GRU and import dropout. Okay. From Keras models and from Keras.class. Okay. For packages I import here and define the method is the LSTM model, passing the parameter which required here input output size, neurons, active function, dropout, loss, optimize. Then we call the first method is sequential, another method is add LSTM, passing parameter neurons and inputs, shape, input shape. Okay, then I will return the model here. Then check the random seek of responsibility here, initialize the architecture. Then from you can check the here the loss of history and min dot Bitcoin history is here. How to stop, how to use step one, how to use dollars. Okay. Another visualizer from an visualizer dot visual input and visualizer package. From Keras utils versus utils import plot model, graph plot using PNG. Then check here the output is a okay. From PyLab import RC frames. Figure 6, can plot the graph mean absolute error you can calculate here. From scalar matrix print from training histogram plus str np dot mean. loss. Model predict the training inputs from sktt-learn. Print the mean absolute error here. The mean of prediction is 4004. We calculate the accuracy. Mean test error, how much percent is having the error. Then import plot PL SPLT, import scalene matrix, import plot dot graph object as go. Okay, you can create a predicted model. Last one, you have to check the accuracy of the model. Okay, how much accuracy is repeated of model predictor passing the test input 69. Let's check the here output array. Then another you have to evaluation on the test time. Print the model evaluate test test. Okay. Then you can check the 127 that 73 is a dataset from 85 US. Okay. Then last one is the PT model summary. You have to save the PT model into class file. Okay, PT model dot extract layer type output. Okay. Total parameters 47,830. Trainable parameters is 47,830. And parameters is 0. Okay. Check the year the total output is here. That's it guys. Today we learned what is exactly prediction of the Bitcoin price, how much we require the exactly how to predictive models is there, how to data is reviewed from this Bitcoin price data. Okay, that's it guys. Thank you so much for the listening video.